Okay, the displacement x meters of a particle after t seconds is given by this equation. Derive an expression for the velocity of the particle. So if we are going to talk about displacement, velocity, and acceleration, I just want to remind you that these are sometimes called distance, speed, and acceleration. Now, they do kind of mean different things, but when we're looking at getting the displacement, if we want velocity and I've got displacement, I have to take the first derivative. And if I want the acceleration and I've got displacement, I need to take the second derivative. So it just incrementally jumps down. Now, if I want to go the opposite way, that means I apply something called integration, which is what we'll learn about in the next term. Same for distance to speed. So if I want to get from here to here, I need to derive it. And if I want to get from here to here, I need to take the second derivative. Okay, so we're going to get an expression for velocity. So I can say that velocity is equal to the derivative of x with respect to t, which is equal to the derivative of this function here. So now when I derive my sine function, it's going to be 4 times, the 2 is the derivative of this, so it'll come to the front, times sine will change into a cos, and then it goes back in the bracket like that. When I take the derivative of the 3 will just vanish. So here I can say that velocity is equal to 8 cos 2t. Okay, and that's the first one. So now I've got an expression for velocity of the particle given the displacement function. Determine the time at which the particle is first at rest and its position at this time. Now, if the particle is at rest, that means that the velocity is equal to 0. It means that its speed is equal to 0 because it's not moving. Okay, and then we want the position at that time. So we want to find when velocity is equal to 0, what is the time? And then once I have this time, I'm going to put it back in to find what our distance is. So first thing I do is I let this equation equal 0. Take the 8 across, 0 divided by 8 will just be 0. Now I'm looking for all of the values where a cos function will be equal to 0. So if I think about that, here's my unit circle. Cos is 0 here. So I'm looking at the 90-degree intervals, or pi on 2, or I'm looking down here at 3 pi on 2. Now, if I travel in the negative direction around my unit circle, that's negative pi on 2, and that's negative 3 pi on 2. That's where they'll occur. Remember, I don't want to touch the 2t until I've got a little bit of a list going over here. Now, we're going to say that time can't go before 0. Initially is like the start, which means that time can't exist before. So I'm only going to travel in the positive direction around my unit circle. So that means that my answers for this will be pi on 2 and 3 pi on 2. Now I can take the 2 across. I'll be left with t is equal to pi. Now when I take this across, it's going to divide as well. It's going to multiply them both by a half, meaning that my answer will be pi on 4 and 3 pi on 4. Remember, if you are watching this video and you're not sure about how I completed one of the steps, feel free to shout out, because they pay me to answer your questions and I get 20 cents for every one, and Mama wants a yacht. So once we're at this point here, now I can say that I found the point. So when it's first at rest will be this first value. I don't need this one. I just don't want you to forget that we can make a list with this information. So that's the first one. Now we're going to substitute this back into our original. So the particle is at rest when t equals pi on 4. Find the position. So we're going to find the position by substituting it back in. Now, sine, this will cancel out to be a half. Sine of a half is equal to positive 1. So 4 times 1 plus 3 is going to be equal to 7. So it does, meters. Okay, so therefore its position is 7 meters to the left. Sorry, to the right. Now, I know that because it's a positive number. So if this is 0 here, 7's over here in the right direction. If it was negative 7, it would mean that its direction is in the left. Okay, next step. Derive an expression for the acceleration of the particle and find its initial acceleration. So we're going to find the acceleration and then we're going to let it equal the time equals 0 and find out what that is equal to. So if I want to find the acceleration, that means I'm going to derive my velocity function with respect to time, which means I'm going to derive 8 cos 2t. So our acceleration is going to be equal to, when I derive 2t, that'll come to the front and I'll end up with 8 times 2 times, cos will change into minus sine, and then I'll be left with 2t in the bracket. So now I've got minus 16 sine 2t. Okay, so now I'm going to let t equals 0, minus 16 sine of 0. Now at 0, sine is also at 0. So that's just going to be minus 16 times 0. So our initial acceleration is equal to 0. So the initial acceleration equals 0. And that's it, we're done.